zeros of the function and the discriminant. In this video, I'm going to explain the relationship between zeros of the function and the discriminant. Okay, let's have a quadratic function f of x equals ax squared plus bx plus c. In order to find zeros of the function, we set up f of x equals 0. That means ax squared plus bx plus c equals 0. Then the solution for this equation is the quadratic formula x equals negative b plus minus square root of b squared minus 4ac over 2a. I want to talk about a little bit about this part, b squared minus 4ac, the discriminant. Let's look at the quadratic formula again. X equals negative b plus minus square root of b squared minus 4ac over 2a. You should memorize this. The discriminant b squared minus 4ac equals 0. When the discriminant is equal to 0, this part will be square root of 0. It is 0. So only solution is x equals negative b over 2a, which is the vertex of the parabola. The parabola will touch its x-axis like this. When the discriminant is positive perfect square, like square root of 16, it is what, 4. So x equals integer plus minus integer over integer, which is rational numbers. So there are two rational zeros. When the discriminant is positive, not a perfect square, square root of not a perfect square will be some irrational numbers. So there are two irrational zeros. And the last thing, when the b squared minus 4ac is less than 0, square root of some negative number, that means you will get two imaginary zeros. So we call it complex conjugates, a plus minus bi form. Let's do some examples so that all of these ideas are tangible. I don't want to solve this equation. I just look at the b squared minus 4ac. When the discriminant is equal to 0, the vertex of the parabola touches x-axis, right? There are only one real solutions. Let's do some examples so that all of these ideas are tangible. I don't want to solve this equation. I just look at the b squared minus 4ac. When the discriminant is 0, b squared minus 4ac equals 0, the vertex of the parabola touches x-axis. So there are only one real solution. But I did, and then after I check, this is the example for discriminant is equal to 0. But be careful, when the equation looks like this, you need to change this to standard form of the quadratic equation, ax squared plus bx plus c form. So you need to change the equation so that you can get a as 4, b as negative 8, c as 4. When we have a positive discriminant, the graph intersects x-axis twice. That means when the discriminant is a perfect square like this, 25 is a perfect square number, right? So square root of 25 equals 5, right? So in this case, you're going to have two rational solutions. When the discriminant is not a perfect square, we'll have, in this case, discriminant is 216. Square root of 216. So this number is irrational number, right? Square root of 196 is 14 and square root of 225 is 15. So in between this number, square root of 216 will be 14 point something something, right? Never ending, never repeating. So it's not a perfect square. It will be two irrational solutions. And the last situation, b squared minus 4ac is less than 0, negative number. That means negative number under the square root. We're gonna get two different imaginary solutions, complex conjugates. Let me show you example. X squared plus 4x plus 6 equals 0, and the discriminant in this case is negative 8. So when we plugged in a, b, and c into quadratic formula, we will get x equals negative 4 plus minus square root of negative 8 over 2. It equals negative 4 plus minus 2i square root of 2 over 2. After we simplify this number, we will get negative 2 plus minus I square over 2, a plus bi form, right? We're going to have two complex conjugates. So for today's lesson, once again, I just want to think about what type of solution I might be dealing with. All I care about is my discriminant. This. I'm going to show you how to use GeoGebra file for quadratic function next time. Thank you. Bye.